In today's lesson, we're going to be talking about higher order derivatives. The only difference between this and regular derivatives is that we do the derivative again. Let me explain that. Let's say we have the derivative x to the fifth. If we wanted to find the derivative of x to the fifth, we would just use the power rule. We take this to the front, subtract 1, so this equals 5x to the fourth. But it turns out that you can find more derivatives of this, or the second derivative, the third derivative, the fourth derivative, etc. This is known as the higher order derivatives. So in this example, if we wanted to find dx squared, which would be the second derivative of x to the fifth, we would first find the first derivative, which is 5x to the fourth, and then we would do the derivative again. We would find the derivative of this new function. So in this case, we would take this 4 to the front using the power rule. We take 4 to the front, then subtract 1 from our exponent. So this turns into 4 times 5 x to the 4 minus 1 power, which is then all equal to 20x to the third power. We can then do this again for the third, fourth, and fifth derivatives using the same process. Let's do some more examples so that way you get the idea, and we're going to do a couple common examples because there's some that are more useful than others. Oh, and something I want to mention, usually let's say we have f of x. If we wanted to note the derivative of this, we would write f prime of x. If we wanted to find the second, third, fourth, and so on order derivative, we can just denote that like this: f double prime of x, or f triple prime of x, and so on depending on what order you have. Pretty simple, just wanted to mention that because it's very useful notation. Okay, let's do another example. Let's find the third derivative, the third order derivative of sine of x. What is this equal to? Well, first let's find the first derivative of sine of x. The derivative of sine of x is equal to cosine of x. This is one of those derivatives you really need to know and memorize. It's very important, it comes up very often. Now we need to find the derivative of this function. This will get us to our second order derivative. The derivative of cosine is negative sine of x. This rule is a little bit more useful whenever you do integrals, which is coming up in Calculus 1, but we're not there yet. And then we just need to find the derivative one more time to find the third order derivative. And the derivative of negative sine of x is negative cosine of x. By the way, this derivative goes on in an infinite loop. You'll never reach 0 like you would with some other derivatives. So the derivative of negative cosine of x is sine of x. And then of course we're just back to where we were before, and it goes in an infinite loop. Anyway, this is a very common example of a derivative you would find using higher order derivatives. And these derivatives come up a lot more in calculus too. Just figured you should know. Let's do another pretty easy example. In fact, this may be the easiest example we'll do. Let's find the third derivative of e to the x. So first we need to figure out what the derivative of e to the x is, and the derivative of e to the x is just e to the x. This is another rule that comes up very often and that you should know, and plus it's the easiest one to remember. I mean, come on, it's literally the same thing. To find the second order derivative, we need to find the derivative of e of x, and that's e to the x as well. And then to find the third order derivative, it's still e to the x. This is a really easy example because the derivative of e to the x is just e to the x, and you just do that over and over, but figured we should do it just for fun because it's so simple. Let's do one more simple example for this video. We're going to find the second derivative, so f double prime of x, of 12x to the fifth. We did a similar example at the beginning of this video. Let's just do another one. Let's first find the derivative of 12x to the fifth. Using the power rule, we take the 5 down to the front and then subtract 1. So this is equal to 5 times 12x to the 5 minus 1 power. 5 times 12 is 60 times x to the 5 minus 1 power, which is just 4. And then to find the second derivative, we do the same thing again. We pull this down to the front, then subtract 1 from the power using the power rule. So then this just turns into 4 times 60x to the 4 minus 1 power. 4 times 60 is 240 x to the 4 minus 1, which is third power. Like I said, this is a pretty simple example similar to the one we did at the very beginning of this lesson. I hope you guys found this video helpful. If you did, consider subscribing because I'm uploading tons of Calculus 1 lessons. If you want to check out more Calculus 1 lessons, check out the Calc 1 playlist listed here, and I will see you guys in the next lesson.